Hello, Jack, and whoever else is watching this. We are on example 6, and this is, I don't know, 1-7, number 6. We've got a lot to do. We are graphing first. This is graphing a piecewise function. All right, so we got two functions going on here. And to graph it, the easiest thing for me to do is change them and make them say like y equals negative 3x, okay? Then that kind of helps me look at it as a linear function. This guy says y equals negative 3, okay? Got it? All right, so y equals negative 3x, I'm going to graph him first. If we just graph this guy, he's like negative 3x plus 0. That's what his linear function looks like. So I start at 0, and then from there I go down 3 over 1. Do you get what I'm doing? Down 3 over 1, down 3 over 1, or up 3 to the left 1, up 3 to the left 1. And so my function looks something like this. Except, are you writing in pencil?
No.
Ruh-roh.
Yeah.
Except, I only want it when we're less than 1 on the x-axis. So I find 1 on the x-axis, which is right here. And I'm like, don't write this straight up and down line, but I'm like cutting him right there at 1. And I only want to graph it if he's on the left side of negative 1. Or the left side of 1, right? On that side. Less than 1, right? Less than 1 would be this little bit right here. So I want to leave that, and I want to get rid of this other side. So I'm going to get rid of this chunk. So I'm going to erase him. Okay? On this side of 1. All right? So I got to do my function again. And he's going to look like this. Okay? That's where he is. He's going to start, and he's going to go that way. Now, is he going to be an open circle or a closed circle?
Open.
Open. He's an open circle because of there's not equal to, right? Okay. Now on this half, on greater than 1, I'm just at y equals negative 3. Okay. So I go to negative 3 right here. This is what y equals negative 3 looks like all the way across there. But I only want him greater than 1. So I'm going to start him at 1, and I'm going to go forever this direction. Okay. And he's going to be Eli, put it away. I am not asking again. There you go. That's what he looks like. Got it? He's like a little slanty L. All right? The pink one was from the top function. The yellow one was from the bottom function. Got it? All right, we're going to do another one like that. Okay? All right. Yeah, not so bad. What? He's two pieces. He's a piecewise function. Now, not always will they meet at the same spot. Most of the time, you're going to have an open circle and a closed circle, like not on the same dot. But this time, I had it overlap. Okay, this one's probably not going to meet on the same dot. We're going to start with y equals x plus 3, which is a linear function, right? Linear function. Starting at 3 and going up 1 over 1, up 1 over 1, or down 1, left 1, and he looks something like this, right? Something like that, right? Okay, but I only want less than negative 1. Negative 1 is right here. So I'm only doing this chunk that I'm leaving, and this chunk goes away, right? So if you want to erase, you can erase. Okay, negative 1 is there. So from here and beyond. Oh, is it an open circle or closed circle? Open, sorry. It's an open circle.
Down 1 over 1?
Down 1 over 1.
Which one?
Well, up 1 over 1, technically.
I'm done. Can you tell me?
Which one? That one.
No.
This is just a number, so you could have written that as 2/3 x squared plus 5/3 x and just done the power rule. Poop.
You weenie.
Haha. Nah. All right, there you go. Okay? The second half. Are you guys all watching? The second half, y equals x squared, is a parabola, yeah? Okay, we're going to graph the parabola starting at 0, okay? And if I'm going to do some exact points in here. So if I do 1 squared, it's 1. 2 squared is 4. 3 squared goes up to 9, like this, right? Okay, same thing on the other side, except I only want him graphed when we are on this side of 1, negative 1, right? So I'm going to have a closed circle here, and he's going to do one of these. Oh, but wait. He has to be less than 2, so I'm going to stop him. I'm going to stop him at 2, and he's an open circle. He's an open circle here and a closed circle here, so he's only doing one of these. Okay, do you see that? And that's what he looks like. He does not go forever to the right. He does not have an arrow on the right side. He only has an arrow on the left side. Do you see how that works? Okay, you're only making that value from here to here. What? I don't know, because it's not supposed to be there. I just can't erase him. Well, maybe I can't. Maybe I can. I can erase them.
It's fine. It's fine.
Open circle. There you go. Okay. Yeah. Yeah. Okay. Happy with that? That's the graph? Good? Moving on to the next thing?
Are these easier than what we had in calc a little while ago?
I don't know. Limits? I don't know. Maybe so. All right, this last one that we're graphing. It's not the last one, but it's the last one we're graphing. This is called the greatest integer function. I don't test you over this guy because I think he's kind of dumb. But he has a time and a place for him. He is called the greatest integer function. Different books write him differently. Some textbooks make 2 brackets where he looks like this. Okay, I'll explain to you what he is here in a second. So that's what he looks like. In some textbooks, he looks like a double absolute value. Okay, so just so you're aware, he might be written 2 different ways. If you see that, that means the greatest integer function. Here's what it is. If I were to make a table of values and I put x in and y comes out, okay? The greatest integer of 0 is 0. The greatest integer of 0.1 is 0. The greatest integer of 0.5 is 0. The greatest integer of 0.9 is 0. The greatest integer of 1 is 1. Then we go to 1.1 is 1. 1.3 is 1. 1.7 is 1. I'm just like making these up, right? The greatest integer means you always round down. So like 2.7 would round down to 2. Okay? It's the greatest integer that is beneath the number that you have, right? Okay, so here's this is a scenario of when this would work. Well, let's do that. So 0 is at 0, and then we go all the way over, and it is an open dot at 1 because that's when he bumps up to 1. And then he goes over and he bumps up to 2. And he goes over and he bumps up to 3. And he goes over and he bumps up to 4. And this is what the greatest integer function looks like, also negative. So he has an open circle on the right and he's a closed circle on the left. So let me explain this to you in like terms that maybe would be a little bit easier to understand. Okay? All right. I have a 3-year-old. I had to think for a second. I have a 3-year-old. Okay? He would be right here. He is technically getting close to being 3.5 years old, which would be like technically here, right? But if you ask him his age, he will still say 3. Even if it's the day before his birthday, which would technically be right here, he is still 3 until he gets to 4 on the nose, and then he bumps up to this exact point right here, right? That's like a way to see how that works, right? So you are 3 years old for the whole year until you bump up to 4 years old. I don't care if you're 3.5. You're still only 3. If you're 3 years old in 364 days, you're still only 3, right? That's how the greatest integer is represented.
Can you go back to the last graph?
Sure. The last graph?
Like, no, like what you just, the X and Y.
X and Y, I just made those numbers up. But anyway, it's all of the numbers always round down, okay? Now here's the tricky part. Let me give you I'll do a separate table. X and Y, ready? Negative 3.2. What does he go to?
Negative 3. Negative 2. Oh, negative.
You round him down. What's down from negative 3.2? Negative 4. He rounds down to negative 4. Does that make sense? Negative 4.8 rounds down to negative 5. Does that make sense? So when you're in the negative numbers, rounding down pushes you to like the one below it, right? Okay. So that's a little bit confusing. A lot of people get that wrong. Okay. So like negative 3 would actually be above negative 3.2, right? Negative 4 would actually be above negative 4.8. So we want to round down. Okay, got it? That's how that works. All right, next one. Number 9, using a piecewise defined function in an application. A salesperson makes a monthly salary of $3,000 along with 5% commission on sales that are over $20,000 for the month. All right, write a piecewise defined function to represent the salesperson's monthly income for X dollars in sales. All right. She makes a monthly salary of $3,000. Okay. All right. So X, let's talk about what X means. And let's talk about what Y means. Okay? X is the number of
Monthly salary. Number
X is the number of number that they sell, right? Like a salesperson's monthly salary, blah, 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 right? A piecewise function to represent the salary. Yeah. X is the dollars in sales. Okay, let's do that. Is the dollars that she sells. So if I'm selling a house, X would be the amount that I sell the house for. The Y value is what I make on the house, right? Like I'm making a commission. So Y is the dollars that I make. Or this is my income. Let's say my income. Okay, got it? So when we make this a piecewise function, we have Y equals, and we have two different levels. No matter what, she's making $3,000. And if she sells less than $20,000 for the month, she's only making $3,000, right? So when I go over here to write my domain, if I'm selling less than or equal to 20,000, I'm only making that $3,000. Do you see how that works? Okay. But if I sell greater than 20,000, you see how this works? If I sell greater than 20,000, I'm making the
Plus 5%.
I'm making the $3,000 plus 5% of what?
X.
Of whatever I made, right? Or whatever I sold. So 5% of X or 0.05X. Does that make sense? I make a 5% commission on how much I sell, but that's only if I sell more than 20,000. Does that make sense? Okay. If I sell up to 20,000, I mean I'm kind of slacking that month. I'm going to make $3,000. That's fine, but I won't make any more than that. You see how that works? Okay. So that's where my cutoff mark is. So figuring that out, establishing what your X and Y is, maybe is the best place to start, so that you know what we're even talking about, right? Okay. Any questions about that? No? That was kind of a weird thing. Okay. They didn't ask for any questions. They just want the equation. So there you go. All right. Last thing. We've got, here we go. Increasing, decreasing, and constant behavior. All right. If we're just looking at this graph, he is increasing from here to this point right here.
Steady.
Where is this point located? Is that right at 40, do you think?
No.
Yeah? Maybe? No?
No.
Should we say he's right at 40?
Do the straight line.
I don't know. Hold on. I got to go back. Find out.
We can say.
There's the straight line.
39.
39? Sure. Okay, so we'll say he's at 39. 39, comma, 2,900. That's where he's at. Okay, let's talk about this point right here. Where is he located at? He's at 120 exactly. 120, comma, 2,900. Or 29,000, I mean.
Are you sure?
Yeah.
I think he's a little
Sure.
off. He is definitely a little off.
A little off of the 29,000?
No. Look at your paper.
Whatever. It's fine.
He's a little
Okay.
looking at my paper.
All right, so here's the deal. We have places where we have a function that is increasing, we have a function that's decreasing, and we have a function that's constant, okay? You know what increasing means. You know what decreasing means. Do you know what constant is?
Stays the same.
Staying the same. All right, now, we write this in like interval notation. So x from what to what, right? We don't care. We don't care about the y coordinates ever. Ever, ever. I want to know from what to what on the x-axis. So this increasing bit right here, from what to what is he increasing?
0 to 39.
From 0 to 39. So we write it as 0, comma 39 like that. Okay? And we do parens, and I'll tell you why we do parens here in a second, not brackets. Okay? He is then switching to constant from what to what?
40 to.
We'll still go 39 to 120.
Oh, okay.
Okay? And then he's decreasing from
120 to 160.
120 to 160. Okay, the fact that we did parentheses instead of brackets means that
It's not exact.
on 39 exactly what's happening.
It's both.
Could be, yeah.
Like, if should we put like a bracket here and then leave this as a paren instead?
Because it's not.
So what's happening at 39 exactly?
It's changing. It's a tippity tip.
It's kind of like a tippity tip, yeah. 39 is neither increasing, decreasing, or constant. It's a place where it changes. So it's kind of one of those weird things. It's kind of one of those weird things where you don't lump him into one category, right? So the fact that we have a parenthesis means up to 39, but not 39 exactly, he is increasing, right? Okay, because at 39 exactly, he's neither increasing, decreasing, or constant. He's just that place where he switches over. What?
I understand why you're doing parentheses, but this is just like not a stupid question, but it's like just a question.
Sure.
So could you put a bracket sometimes it's backwards.
But then you would have to do the same with.
That's a good
with
thought.
160. You would have to do the same with 160 then.
You can have a negative too.
It stops at 160.
That's a good question.
You can go backwards.
What I would say to that is that 0. Okay, here's my response to that. I think we always will use parentheses, and here's my response to that. That was a very good question. She said, why don't we put a bracket at 0? 0, we don't know on this, we don't know anything that happens on this side of 0 because like you can't have negative time or whatever, right? So at 0, we don't know if he's going up or if he's going down, like on that side of it, right? So I don't know if technically he's increasing or decreasing at 0.
Because he could land and then could instantly take off.
Right. So let's just say a parenthesis no matter what. Okay? No matter what, you're going to use parens because at those places where he switches over, he's neither increasing, decreasing, or constant, which actually makes our job easier. Okay? All right, so let's do this one. Last one.
Might ruin the plane's wheels.
Intervals where he's increasing, decreasing, constant. So let's talk about what he's doing first. Let's just start from left to right. So from here to here.
Decreasing.
He is decreasing from what to what?
-4 to -1.
-4 to -1 because we're not looking at any y coordinates, we're only looking at the x's. So from -4 to -1 he's decreasing. -4 comma -1 paren. That's where he's decreasing.
The right word.
Yes.
Guess what?
Yes.
Guess what?
Yes. Okay. Then from -1 to what? -1 to 2 he is
Constant.
constant. And paren. Okay. Then he switches and he goes increasing from
2 to 3.
2 to 3, 2 comma 3. We're looking at the x's. Okay, and then he goes back to decreasing again.
From 3 to 5.
From 3 to infinity. Okay, now I have 2 units of decreasing, so that means we're going to put a union in the middle. And I'm going to put him up here. I don't know. When you have two intervals, you do a union in between. Okay? Got
Is
it?
it positive infinity?
Yeah, positive infinity.
Well, he also goes down.
Yeah, but you're only looking at the x's.
You're only looking at the x's though. See, see? You see how it's confusing? Good thought. You're only looking at the x coordinates. So yes, I get it. I'm glad you brought that up. It is going downhill, but it's only positive infinity because you're only looking at the x's. X's are going this way. Okay? Got it? It's not negative infinity. Okay? Happy with that?
No. Yeah, because
That
it's
is.
a y coordinate spot, but it's not a
I
y coordinate.
know, right? Yeah. But it's not. Yeah. Oh, yeah. Yeah. Very good. Okay. All right. That's it.
I want to look.
Oh no, we have an example 11. What? Oh.
Sorry. We do it tomorrow.
You're killing me.
We
You're
do it
killing me.
tomorrow.
No.
Tomorrow.
Relative maxes and relative mins.
Tomorrow.
We need this for our homework.
You do need this for your homework. For the graph, determine the location of every relative or any relative maxima. Maxima is the plural of maximum, which is one number, right? So we have relative maxes. How many relative maxes do you have?
1, 2, 3.
Relative maximums, high points. Only one high point.
A 2 high point and a 3 high point.
Nope.
Infinities.
Nope, but those aren't points though. Okay?
Just at the 2.
All right, so the high point is at 2, 1. Agreed? Now, there is a difference between a relative and an absolute.
We don't have that word.
Absolutely.
Absolute maximum. Okay? In this case, there are no absolute maximums because he continues up and up forever and ever and ever. But relative to all the points around it, this is a high place, right? Relative, absolute. Okay, so now we have relative mins. How many relative mins do I have? 2. And they are at?
-5, -1.
-1, -5.
Oh, yeah.
And at 4, -2. Do we have any absolute?
Yeah, what does absolute mean?
Absolute means absolutely the lowest point on the graph.
Oh, so the -1, -5.
-1, -5 is an absolute min. Now he is a relative min and an absolute min. So you list him in both places. Okay? Does that make sense? Relative, absolute. Do you see the difference between the two? They didn't ask for absolute. They're only going to ask for relative. Relative anything is just like the hills and the valleys, right? The highs and the lows.
That was pretty.
Okay? Got it? Can you have 2 absolutes? Can you have two absolute mins and two absolute maxes?
Unless they're the same point, I guess.
If they're the same.
Yeah, if this looks like a W, right? Like where they're the same here and here, right? That would be a case where you don't even go there, Carter. Don't even go there, Carter. Anyway, you can have two absolute mins and two absolute maxes. There you go. That's all I will say.
On the homework. though.
Goodbye. There's your homework.
On the homework, it only asks for the relative. though.
What?
On the homework, it only asks for relative.
Yes, on the homework it only asks for relatives, so you're fine. Okay, goodbye, Jack.